Hello, I'm the multicellular Mr. Daycock, and today I'm going to be teaching you about arithmetic series. Now, arithmetic series are closely related to arithmetic sequences. So let's consider an arithmetic sequence first. Let's consider the sequence 2, 5, 8, 11, 14, etc. with A equal to 2 and D equal to 3. Now that's a sequence. What's an arithmetic series? Well, an arithmetic series is the sum of the sequence. It is in fact another sequence itself. So the first term of the arithmetic series, S1, would just be 2. The S2 would be 2 plus 5, which is 7. S3 would be 2 plus 5 plus 8, which would be 15. And so on and so forth. Each part of an arithmetic series is the sum of all of the terms up to that point in the arithmetic sequence. So again, we could add on another one. We'll get S4 would be 15 of all three terms before, plus the 11, which would give us 26. And then the S5 we'd also have to add on the 14, and we get 40, and so on and so forth. So this is a sequence in itself. This sequence is not arithmetic. In fact, it would be a quadratic sequence because it does not have a common difference. But it is an arithmetic series because it is the sum of an arithmetic sequence. Now what we want is we want a formula. Let's say we have a sequence A plus D, A plus 2D, plus all the way up to A plus N minus 1D. And what we want is Sn of this sequence, which is going to be equal to all of the terms added together. And this isn't very nice. This isn't easy to calculate at all. But, well, it is quite easy with a nice little trick. So the trick we're going to use here is we are going to write out the sequence again. And we've got all of these different terms here. And I'm going to write out the sequence again, but backwards. And then here we'll get A plus N minus 2D, because we've got one less, because I'm writing the sequence backwards. And if we think here, this here is going to be A plus N minus 2D, the term before the last one, plus A plus N minus 3D, plus dot dot dot, all the way up to, or here we'll have just A plus D, and here we'll have just A. And you can see that that's our original A. This here is the blue term that I coloured in, and up right at the top we've got our pink term here. We just flip the entire sequence around. And now what we're going to do is we're going to add the two series together. We're going to add both versions of Sn together. So on the left hand side, Sn plus Sn is 2 lots of Sn. And on here, what we're going to get A plus A is 2A. And the rest is just the same. We haven't got any D's, so we've just got N minus 1D. Here, we've got 2A's. And we've got N minus 2D plus 1D. Well, that's going to give us N minus 1D. We've got N minus 1D. Now you can check that out with expansion. D plus N minus 2D is equal to D plus 2N. Dn minus 2d, and then d minus 2d is minus 1d, and then factor the d out again, and we've got exactly what we need. Here we've got, again, 2a, and then we've got 2d added onto n minus 3d, that's going to be n minus 1d again, plus dot 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 all the way up to the end, which got 2a plus n minus 1d. And hopefully now you can see that every single term here is exactly the same. We're just adding up loads and loads of these, and the question is how many of them? Well, there are n terms to the sequence, aren't there? So what we're going to be left with is 2Sn, 2 lots of our sum, is going to be equal to n lots of 2a plus n minus 1d. And then that's going to give us that Sn is equal to n over 2 lots of 2a plus n minus 1d. And now we have a formula for any arithmetic series with n terms, first term a and common difference of d. There is an alternative way of writing this as well, because if you notice that this is here, this and this is in fact the first term plus the last term. So sometimes people write this as Sn is equal to n over 2 lots of the first term plus the last term. And that can be more useful at times. And let's go into some example questions of how we'll use this. Calculate the following arithmetic series. So there's 2 ways of doing this, one with each formula. Let's use the first formula first. Sn is equal to n over 2 lots of 2a plus n minus 1d. Now what we'll need to do here is work out how many terms there are in the sequence, because otherwise we're not going to be able to do anything with it. This sequence has a common difference of 6 and a first term of 1. And we know that the last term, the nth term, so un, is equal to 121. But we also know another way of writing un is a plus n minus 1d is equal to 121. We know a and d, so we get 1 plus n minus 1 times 6 is equal to 121. Subtract the 1 and we get 6 lots of n minus 1 equals 120. Divide by 6, we get n minus 1 is equal to 20, and so n equals 19. And so there are 19 terms in this sequence. Nope. And n equals 21. So there are 21 terms in this sequence. And so with that in mind, we can now calculate Sn. So Sn is equal to 21 over 2 multiplied by 2 times a is just 2, plus 20, n minus 1 is 20, times by 6. So Sn is going to be equal to 21 over 2 multiplied by 20 times 6 is 120, plus 2 is 122. 122 divided by 2, we've got 21 multiplied by 61. And to work out 21 multiplied by 61, all we're going to do is, of course, standard multiplication. And we get our answer of 1,281. So Sn is equal to 1,281. Now, let's use the other option where we've got Sn is equal to n over 2 lots of a plus l, where l is our last term. Well, we need to work out n either way, so we still need to work out that using exactly the same method. So imagine we've done that. We will get Sn is equal to 21 over 2 multiplied by 1 plus 121. And as you can see, we're already at the point where we're just going to get 21 times by 100, 21 over 2 times by 122, and that's going to work out in exactly the same way as 1,281. Okay, next question. An arithmetic series has first term of 8 and common difference of 7. Find the minimum number of terms needed for the series to exceed 1,000. So we want Sn to be greater than 1000, which means we want n over 2 lots of 2a plus n minus 1d to be greater than 1000. But we know a and d. A is equal to 8 and d is equal to 7. So we get n over 2 lots of 16 plus n minus 1d, well that's 7 lots of n minus 1, and we want that to be greater than 1000. Now this is just a matter of expanding, so we get n over 2, in fact let's multiply by the 2, so we get n, we get 16 minus 7, that's 9, plus 7n needs to be greater than 2000 because we multiplied by the 2. Then expanding this out, we get 9n plus 7n squared needs to be greater than 2000. And then rearranging that, we're going to get 7n squared plus 9n minus 2000 has to be greater than 0. And at this point, you can just use quadratic solver or use quadratic formula or anything like that to get your possible answers. And you'll get two answers of, well, your critical values for this inequality will be two values of n equal to negative 17.56 and n equals to 16.27. And those are your two critical values. Now the negative one is obviously not something we're going to worry about. That's not our, it's not going to be on our series because our series starts at 1 and goes up. So we're looking at this. So what we need is for our n to be bigger than 16.27, and therefore the answer to the question, find the minimum number of terms needed for the series to exceed 1000, it's 17 terms. Okay, thank you very much for watching, and I'll see you in the next video.